Hey everyone, this is Matt with Learn Everything About Design, and welcome to part 3 of our 3-part series going from scan to part design. Now remember, we are using a Revopoint Mini2 3D scanner. We are an affiliate channel, so if you are looking to purchase one and use the link in the description, it does help us out. There is also a code LEADREVO100, and that'll get you $100 off the purchase of a Mini2 scanner. So in this video, we are jumping into Fusion. We're going to be doing the CAD portion of our design, getting a 3D part that we can print, and then put it back on this RC10 truck. Now this is probably a tricky part, and I get a lot of comments about how do I reverse engineer this part. And when we're looking at scan data, it can sometimes be a little tricky. So what we're doing today is we're not reverse engineering a part, but we are going to design a part that fits and replaces the original. Now, it might seem like we don't need to get a fully detailed or a highly detailed scan when we're doing something like this, but to have the best data possible when we go into CAD is always helpful. So we're going to be diving in, we're going to be making our new part, and at the very end of this, we'll put it on the truck and cross our fingers and hope it fits. So without further ado, let's go ahead and hop into Fusion and start modeling.
All right, so now we're in Fusion and we're going to begin modeling a cover. One of the benefits that we have here is that we're not trying to exactly replicate the cover because we have one. We don't need to. So we can use it as a guide and make sure that we have enough room or clearance for all the things underneath it. Now, luckily for us, these covers are actually pretty loose in tolerance. There's no seal or gasket or anything. It keeps dust out, but it's not going to keep water or anything from really getting in there. So we're just going to use it as a loose guide, and we'll start by going to our mesh tools and inserting a mesh, selecting from the computer, and finding the OBJ. So again, we can use OBJ, we can use an STL or 3MF. We cannot use the PLY, so make sure that if you are using RevoScan that you don't save it as a PLY if you're planning on bringing it into Fusion. While we can use PLYs for certain things, the inserting a mesh is not one of them. Now, one of the big downsides that we're going to have to deal with is the fact that the scan is not aligned. Now, the way that scans are aligned in RevoScan is essentially the orientation of the scanner relative to the object for the first frame. Now, lucky for us, this is relatively close, and all we really need to do is sort of rotate it. And that's probably going to be close enough, but it's not perfect. And I'm going to show you a way that we can get it closer. Now, in reality, you would want to make sure that you have it perfectly aligned to your coordinate system. Because this part is revolved, this portion here, we would want to be centered about the origin. And this bottom edge is essentially flat. So if we look at it from the top, we would want this edge to be horizontal, or some orientation of that. I'm going to hit Control and 4 on the keyboard to get rid of my edge display, just so we can see what's going on. So right now, this edge is essentially vertical. This is essentially vertical. And this is the orientation, roughly the orientation that it is on the truck. So we can either keep it like this, but center this about the origin, or we can try to rotate it so that this bottom edge is straight. Either is perfectly fine. But I'm going to turn my origin on, see where it is. And I'm also going to create a new sketch. Now, the reason I want to create a new sketch on this top plane is this is going to give me some references. So I'm going to put a circle here. I don't really care what the size is. And I'm also going to put a horizontal line. Now, if you want to follow along, I am going to include a Fusion file in the description of the video here that has the mesh inserted, but not rotated or moved at all. So if you're trying to follow along with this, you can. My guess is you're probably not going to, but feel free to if you want. So what I'm going to do with this line is I'm going to drag it up and see how well it aligns here. And it actually looks pretty darn good. And I'm going to drag this one up and see how that aligns. And that actually looks pretty good as well. So I think with this orientation, I'm going to go ahead and keep it, but I do want to move the mesh. So what I'm going to do is go to Bodies, select this, and use Move Copy. And I want to move it so that that circle is essentially centered on that object. Doesn't have to be perfect. Again, with RC cars, the tolerances are fairly loose. All the suspension pivots and all that stuff, they have a lot of play in them. It's not like we're designing a highly engineered part here, but this is going to get us close enough. And the main reason that we want to do this, and I can go back and delete that sketch. I actually don't really need it. We didn't attach to it at all. We only used it for a visual reference, so I don't need to keep it in the design. But now we have our object centered at the origin. Now there's another part to this that we need to make sure we understand. It's not really in the right location. We have our coordinate system here, but again, I'm going to create a sketch. I'm going to use a horizontal line, and I'm going to put this as a midpoint at the origin. And again, I'm just going to use it as a loose reference, move copy, and bring this down. And the main thing I'm looking for here is I want to make sure that the bottom is flat, and right now it's not. You can see that it's just going below here and it's just above here. So one thing we can do is we can rotate it. I'm going to try to go a full degree, and it looks like negative, and that's a bit too much. So we can try negative half a degree, and let's make sure we got a negative here. And that looks pretty good. You can see the cut's not perfect, but that actually looks pretty consistent here. So I'm going to say okay. And I don't need that sketch anymore. And I'm going to do this one more time. So from this view, I'm going to go ahead and create a line. Again, horizontal. Select the origin, make it midpoint. And then we're going to select our object and say move rotate. Now for this one, I'm actually going to reset the pivot point at the origin because I don't want it to be rotating about some point up here. I want it to be rotating about where it's touching or crossing the origin. So if I try half a degree here, again, it looks like it's negative. That gets me pretty close. So from that orientation, it looks pretty good. From this orientation, it should still look pretty good. Remember, we did kind of a manual cut across the bottom, so it's not going to be perfect, but this at least gets us pretty close. So I'm going to turn my origin back off. Now the origin is centered, and we can move forward with our design. So I'm going to do a quick save, and I need to pick the right location. And we're going to call this RC Truck Gearbox Cover Design. So now that it's here, there are a couple things that we can do. We can use things like mesh section sketches, and we can get information off of this. But again, the only thing we need this for is just sort of a rough approximation. So the only thing we might want to use a mesh section sketch for is actually where this intersects with the bottom plane. So on our mesh tools, we're going to create a mesh section sketch off of this body. For the section plane, I'm actually going to go to my origin and select that bottom plane, which is not going to intersect the object because again, it's just barely above. But if we pull this up just slightly, that should give us a nice section that we can then create a mesh section sketch and apply some things like lines and arcs to them. And then we can push that down to our plane. So what we're going to do is I'm going to hide that. I'm going to go into my sketches, and I want to edit this sketch. Then I can go to create, fit curves to mesh section sketch. This is where one of our bolts is. So you can see that right there. And this is the other location. It's got a little bit of a bump there. Kind of see that. And the main thing I want to do is I'm going to try to fit a circle to this, and you'll notice that it's not working because it thinks that it needs an entire circle here. So then we're going to switch to arc, and we can maybe start somewhere about here and put it on there. And that should give us an arc. We can do it again on the other side if we want. But if we hide our mesh section, we should have an arc. And you can see how close that center point of the arcs are to the origin. So that's a pretty good sign. So again, this is going to be a loose approximation, but we can use these tools such as fit curves for a straight line, and we can put maybe a straight line over here, and we can do another one. So we'll say, okay, we'll repeat that command, and we'll maybe do another line here. Okay, we'll repeat that command, and then we'll do an arc. Maybe we'll just do an arc section up here. And again, if I hide the mesh section sketch, now what I'm starting to do is build that profile, build that outline. Now, if we bring our mesh back, we do have a flat spot right here. So we might want to use a straight line and just try to fit a straight line here and say, okay. Now, this is obviously not the full profile, but the benefit of doing this is now we can do things like extend this out. We can extend all these lines out further, especially if we lock them in place. So if you select the line and use the lock, and we'll do the same thing here, and we hit escape, that leaves the endpoints free and we can carry them out. So we can sort of pull these out. We can do this one here and this one here. And then if we bring our mesh back, you should see that those straight line sections are now in line with the rest of the geometry. Now with the holes, these are relatively small. Again, they're about 2.75, 2.8 millimeters, about 0.11 inches. We can do a mesh section sketch and try to fit something there. But in reality, again, with the loose tolerances for what we're dealing with, we can probably just visually get it close. And I'll do the same thing down here. Now, for a higher tolerance part, we would definitely want to measure it. But for this part, I think we're okay. Again, I measured it at about 2.8 millimeters. And we'll do the same thing up here. I'm going to make this equal to this one because they are the same. And just make sure that they're sort of in the right location. And once I'm happy with their location, I'm going to fix its center point. And same thing down here. If I'm happy with its location, I'm going to go ahead and move it around just till I'm happy with it and then fix its center point. And once again, this is just going to be the starting point for our shape. We can always add more to it, but the starting point for our shape. I also want to include this sort of slotted section here. We're going to have to create a plane for where that goes. That's something that we're going to have to do for this upper section as well as maybe where this lip is. But for right now, I think that I just want to include that geometry. So I'm going to go to Create, Slot, and a center slot. I'm just going to manually pick where the centers are and drag it out. And then just move it around until I'm happy with its shape and its location. You can see this point here is the center point of that arc. So in reality, those two things should be at the same location, and you can see that it's pretty close. So again, even though we are manually moving things around, we are pretty close to our mark. It's also a good idea for us to lock these in place. When you use mesh section sketches, they are not going to be constrained to anything. So a mesh section sketch is essentially just taking a snapshot of where that is in space, and then that's what you get. So fixing those in space, even if you allow the ends to sort of float around, that is a sort of a good rule. Now, obviously, when we design this, we want these to be tangent, but right now, these are just references for us that we can use to know where things like straight edges are going to be. For right now, I'm not worried about that. The only thing I'm concerned about is the hole locations and some of these other sort of obscure references. So we're going to put a circle here. I'm going to make sure the circle is at the origin and it's not snapped to some of those others, because we're going to make sure that those other references are truly concentric. And we're going to go to the outside, which will be the outside of that fillet. And it's not perfectly centered, but it's pretty close. I think it's close enough for what we need. What we could do is move the entire object a little bit more if needed, or instead of having it concentric with the origin, which we just visually sort of positioned it based on that, we could use one of these center points, for example, that one, and see if that's any closer. And use the same center point and bring this one out. And it actually looks a bit closer, so I'm going to use that. I'm going to give it a dimension. 19.5 seems like a good number. And if I can type it in right, we'll say 19.5. This ID for that plug that's going to go in there is going to be about 12.75, maybe 12.5. It's a pretty loose fitting plug, so we only need to worry about the minimum diameter here, the inside diameter, and that's going to be fine. We could also add a couple of additional references just so we have them in a single sketch. So maybe to this point, it's the outside of that root fillet. and maybe another one to where that face is, and then call that good. So once again, I'm just going to give these diameters, looks like about 27 millimeters, and this one's about 33. Doesn't need to be perfect because, again, we're making our own design, so we don't need it to match. And the last thing I want to do is give this some dimensions. So 5.75 and maybe an overall length here, 5 millimeters, it seems about right. And I'm happy with that. It's going to be just inside of that fillet. So in reality, that might be 6 millimeters. Now we'd go to the outside of the fillet. Yeah, it looks pretty good. So that's going to be our rough process. I get a lot of questions on how to reverse engineer parts. This, I would not call this traditional reverse engineering because we're creating an object that just needs to fit in a certain location, but it's not highly toleranced. Now, if this was highly toleranced, what I would do is I would make sure this bottom edge is flat. I would make sure that I had precise locations for those holes. But because I know that we're talking about loose tolerances, a plastic part that can flex a little bit, and knowing that it's not sealing really anything, there's no gasket or anything that goes on the bottom of this, this is going to be good enough for what we're doing. And I'd probably say for the vast majority of parts that people are trying to create or reverse engineer, or that term, this is probably good enough as well, because 3D printing has its own tolerances, and by the time we actually get in to create something like this, those tolerances are going to be lost once we're printing something. So just keep that in mind. Now, the next step in this process, in order for us to make planes that are actually snapped to something, we would need to go into direct edit mode. Now, we don't have to do this, but I'm just going to at least mention it or show it because in a lot of cases it is pretty helpful. When we go into direct edit mode, this gives us access to actually select individual vertices and triangles. So if we're trying to make a plane, let's say a plane through 3 points, we can select 3 points on this face, and that gives us a plane. Now, the downside to this is that plane is not going to be parallel with our default XY plane. Now, it might be relatively close, but it's probably not going to be perfect. And same thing if we make a plane off the top here. Go ahead and select those. Now we have a plane for the top, probably not going to be perfect. For what we're doing here with this part, it's likely fine for us to just visually estimate where these planes are. This section here is kind of tapered, so it's probably not going to give me a great result, but that's the process that I would go through if I needed those reference planes. Now, a true mesh editing software, which Fusion is not, we do have direct modeling tools and editing tools for mesh bodies, but a true piece of software that is meant to deal with scan data like this will have options for you to select points and make a plane parallel to another plane. So for example, if we bring back our XY plane, so we've got that XY plane there, and we measure between that and this plane, you can see that we're about half a degree off. Now, in reality, that is very small. That half a degree is probably fine, but it is a compounding issue because if we go from that plane to the top plane, we're another 0.3 degrees off. And if we take a look at that plane down to another plane, these are just sort of compounding issues. So we're going to eventually get to a point where we're just going to be kind of off with these. One of the benefits that we have here, though, is now we can say measure from a point, let's say the origin, up to this plane, and we can get a distance. Even though the plane is not perfectly parallel with the bottom, we can say, all right, well, it looks like we're at about 29 millimeters. So we can, with pretty good confidence, say that the overall part is probably 29 millimeters tall. Because 28.799, based on our references, probably 29 to 30 millimeters tall. We can measure it, of course, with calipers, but sometimes you don't have that option because the object's too big or too bulky or just can't measure it. But in this case, that gives us a good reference. We can also do the same thing with this plane. And we can say that first step, realistically, is probably about 15 millimeters. We have comments inside of Fusion, so I'm going to say first step, 15 millimeters. Second step, is 29 millimeters, and that gives us those heights, and we can post that. We can also measure to this plane here in case it's different than this one. Every time we post a comment, if the design is unsaved, it's going to create a new version for you, so you will just have to wait for it to save it. Sometimes, for some reason, that's going to just take a little bit longer, especially when we're dealing with potentially a mesh file. Just be patient while it's doing that. So let's go ahead and just do one more quick measure. So again, from the origin point up to this plane, I'm going to hold down the left mouse button because that plane is just under that top mesh. And it looks like 14, so looks like it's a little bit under, but it could just be based on my selection. But that does appear to be just slightly under. So I'm going to go ahead and put oval face. I'm going to call that 14 millimeters and post that. So it's just nice to have those comments in there, especially when we need to measure stuff. When you're making comments in Fusion, you can also grab a screenshot by clicking on the camera icon. And that way you can do things like see the measurement on the screen. So we've got the plane selected. We've got this selected here. And then we can just say, ground to face 14 millimeters. And then when we post that, we'll have that image that we can go back to and we can click on. And depending on how that was taken, if the numbers are visible, it'll bring that image up. We can zoom into it if we need to and fit to screen. But that's just a good way to keep notes inside of a design in Fusion. So for us, I'm going to hide all of those. Now that I've got some rough dimensions, I'm going to hide the origins. I personally do not like to model with them on. I know a lot of people do. And I'm going to do a quick save so I can stop rotating this around, and then we will begin to model. So anytime you're modeling a complex shape, and to get started, I'm going to stick pretty close to some of these original shapes so we can see how it's done. Generally, what I would do is I would start with this lower face. So there's a little bit of a lip here, and I want to model that bottom lip. I want to figure out where that thing is. So I'm going to start by creating a new sketch. This is going to be on my XY plane or my top plane. I'm going to hide the mesh body, and I'm going to use some of these references. So I don't want to bring all of them in, but I'm going to say project this one, project that one, obviously the holes. I'm not worried about anything on the inside yet, and this arc and this line. And then I can hide that original sketch. And now I've got these. I'm going to grab them, make them all construction, which is X on the keyboard, or you can click construction here. And this is my starting point. Now, obviously, this circle, this arc, did not end up perfectly centered at the origin. And again, that's just because we manually moved it into place. So I'm going to use the center point of that arc, and I want to bring this circle out. This is going to be my reference for adding lines. I also want to create a circle here. And this is a good starting point. I'm going to create some circles here. So these are going to be snapped exactly to. So I could turn these off. These don't have to be construction, but I'm going to go ahead and make them equal. I'm going to give them a dimension in this sketch of 2.8. Now, because this is going to be a 3D print and tolerance is probably going to be an issue, I can make them a little bit bigger. And then I'm going to add a second circle, and I'm going to make this one 4.5. If you need to bring the mesh back to get an idea of how big that is, so you can see 4.5 is not quite big enough. Let's go ahead and make it 6 millimeters. That looks like it's about right. And then we'll do the same thing over here. Now it looks like this one at about 6 millimeters, a little bit big. So maybe we'll make this one 5, and 5 looks about right. So basically what I'm looking for is when it hits that edge there, and there is a little bit of a recess here for the head of the screw. That seems to be smaller than 5 millimeters. It's kind of hard to tell, but for our design, we can keep it at 5 and it'll be fine. So with those in play, we'll go ahead and hide this. Next, I want to create a straight line, and I'm going to do this by snapping to these circles, and then I'm going to add tangency. So tangency to that one, and tangency to this one. And that should get pretty close, if not exactly on this reference line. So if we zoom way in, it's going to be a little bit off. But remember, we're dealing with mesh section sketches, and as long as that's pretty close, I'm happy with it. I'm going to do the same thing on the other side. Again, I'm just going to snap to the circle. This is a bit different because we've got this horizontal reference. And what I want to do is I want to go to a point out in space, and then I want to go to this circle here. So I'm going to go tangent to this one. I'm going to go tangent to this one. And then I'm going to make this line here horizontal. And again, what I'm looking for is to be relatively close to those reference lines I brought in. It doesn't have to be perfect. If you want to measure, it's probably going to be less than a degree. Let's say 0.8 degrees. So again, pretty darn close for our loose references. And that's, if we bring this back, that was the straight line, and there looks like there's a large fillet on that corner. That's something we're going to do at the solid level. I'm going to leave the sketch pretty bulky here. And that looks like it's okay. If we hide this, we now have this pretty big profile here. If you want to clean this up so you don't have to select so many regions, you can. Not really needed in Fusion. And generally when you trim stuff, you'll start to lose references. So you're going to get constraint warnings. And this crosses over so many other little things. So you can see all these little pieces in here. And as soon as we get to a certain point, we're going to start losing those references. So my personal preference is to leave all of those there. If you want to clean this up a bit, I suggest going to the break tool. So for example, when we use break, it'll allow us to keep all the constraints and all the references, but it'll let us break the lines up in basically at their intersections. And what that allows us to do is make it construction. So for example, if I click here and hit escape, that line can now be converted to construction, which means that I don't have to worry about selecting it. It's a bit of a process to do, and the tool can get hung up, but you may just want to go around and play with that. Again, I don't think it's worth it. I'm okay with just selecting all the profiles, but if you want to, then by all means do that. So for this, I'm going to bring my design back. I'm going to say extrude, and I want to take all of these sections up. Again, this is where using things like break would be helpful. Make sure that we do select all the regions except for that hole. We want this section as well, section on the outside, and essentially everything but that hole. Now, if these lines overlap, you do need to pay close attention. We do have a gap there, and we do have a gap there. That looks pretty good. So from the side, we're going to pull this up, and it looks like about 3 millimeters. It's going to be good. I do have my edges off, so Control and 6 will bring the edges back, but that's kind of tough when you're dealing with a mesh. One thing you can do to simplify that is go to opacity control and turn the opacity of the mesh down a bit, but that is it is still very tricky to see. If you don't mind having the edge display off, then you can do that, but the edge display on with mesh bodies can just be a bit much. So I'm going to go ahead and set the opacity back to 100%. But that is one way that you can go about modeling. One thing I do like to do is change the color of the body. So A on the keyboard for appearance, or you can right click and go to appearance and just make the part that you're designing. It's going to go ahead and make it plastic, translucent, and something that we can see easy. We can go ahead and just drag it on here, make it red. So that way we can kind of see it coming through. Now, the original body would have been tapered because it's drafted. We don't have to worry about that for 3D printing, but some of these features, like this wall, you can see it's starting to come outside because the original was drafted and tapered. We're going to do a quick save. And then we want to take care of this fillet in the corner. So in reality, that's probably going to be the same radius as this, which we didn't actually put a radius value on it. If you want to, we can come back in, and I'm going to grab it over here so I know it's right. 17.452. It's pretty obscure. But we're going to add a fillet here. And as we start to drag that in, I'm going to enter 17.452. One thing that we could also try to do, let's see if this will work. This is untested, but we'll try it. Go back into that feature, and I'm going to click on this dimension, and it won't let me do it. So we'll just leave it at that. So that looks pretty close. Let's go back to home view, and let's make sure we do a quick save. And remember, initially we talked about we're not going to replicate this design, and we're going to make our own. Now, this is quite a bit more space than's needed for the clutch setup that's on the RC truck, but I'm going to use this as sort of the bare minimum, because sometimes there are accessories, you can get different clutches and different springs and hardware. So we want to make sure that we don't encroach on the space that is inside of what's here, but we're not going to create the same design. Now, the base is currently its own solid body, and we're going to keep it that way. But what we want to do is we want to make sure that we have a way that we can reference that geometry. Now, this upper piece here, we're probably going to slap on last. But what I want to do is create basically a surface that is where this is, and just sort of carries across. So the next step for me is going to be to create a plane. I'm going to hold down the left mouse button, select X, Y, and then I want this to come up to, let's see, it's going to be hard because let's bring the construction folder back on. I want it to be about the location for these, which looks like it's about 15 millimeters. So it'll raise this one up just slightly, make sure all these other ones are hidden, and we'll say okay. So that's going to be a good reference. It's going to be parallel to the base that we created. Remember that we did hack off a little bit of the bottom of that mesh, but now we can start to build our shape. Now you can do this all with solid tools, but I find that when I'm building complex shapes, I like to go to surface tools because I can work one face at a time. So I'm going to go over to my surface tab, create a new sketch on this plane, and then I need to bring back one of my sketches that has a center reference. So I'm going to hide the mesh body and hide the solid body for now. And remember, this is just a little bit off, but I want to bring back that reference. So I'm going to make sure that I project it. That's P on the keyboard. And we're going to just create a circle here. You can bring back the original sketch, sketch 4, and I can grab this reference here. So hit escape, bring back sketch 4, double click this, and again, P to project it. And now essentially what we want to do is figure out the size of the shape. Now again, remember, I'm not going to encroach on anything that is smaller than this shape. So I'm going to give it, looks like about 33.5 millimeters. It's going to be the rough size that I need. And now I want to connect these together. So using my line tool, I'm going to go from this one to this one. We'll make this tangent on both sides. And then we're going to do the same thing over here. So just sort of work our way over, make sure that it is connected and tangent, and then we'll use tangent on the back side as well. So basically what we're going to be doing here is we're going to be creating a patched surface, a flat surface. Now this can get a little bit tricky when we've got multiple profiles. So if I select patch, I have to select all of these profiles, but when we hit OK, it will be one surface. I'm going to use Control and 6 to bring my edges back. Now we've got a single surface. If I bring back my original thing here, you can see that we've got that surface. I am going to make it a different color. Again, red, so A on the keyboard, just so we can see it a bit better. And this is going to allow me to start building my new shape. Now, the new shape is going to be built on top of that base, the solid, but we're not going to connect to it yet. And the main reason is because we need a thin wall part. Now, when we're 3D printing, we need to think about things like the nozzle size that we have. My machine currently has a 0.4 millimeter nozzle in it, which means I can probably print a 0.2 millimeter wall if I really want to try. Probably not going to go that thin, but that's something that we need to keep in mind. If you're running a 0.6, 0.8 or bigger, you're not going to be able to print those really fine lines. You're going to have to do something a little bit bigger. So this is the start of our shape. I am going to go back to perspective with ortho. I like to just look at it with perspective a bit better. And I think I'm going to come back and potentially remove those. I have to think about that a little bit. But I want to start by building the outside, and we can always trim some of it away. So looking at our shape, I'm going to bring the solid body back, bring my edges back, so Control and 6. And we can start by doing something like a loft. We can pick this straight edge here and this straight edge. And I'm just going to keep it like that. If I want to, I can add to the profiles as long as they're connected. So you can see we can start to build that outside shape. We can add to this profile and just kind of play around with it. We do have the straight section here, but that's not going to work because of this base. We'll have to do something else. And same thing over here. We could actually get away with it on this side over here. And you know what? I'm just going to work my way all the way around with the exception of that side there, just because of that opening. So that's probably going to be the new shape. You can see it's getting a little twisted here. That's something that we want to make sure we identify and avoid. If that happens, then what you want to do is hold down Control and get rid of some of these selections. So Control and maybe stop right there. And then we'll do a secondary loft. And the reason that we want to do that is because now with the secondary loft, we can add a guide rail using that original surface, and we can make sure that one's tangent to carry that shape over. And that'll prevent us from having that sort of weird ripple that happens. And generally that happens, and you can kind of see it over here as well. If you are trying to loft too many edges, even though we're keeping the same shape, sort of top and bottom, a lot of times it starts to twist in the middle and it doesn't know what to do. So I'm actually going to go back to that original loft. I'm going to get rid of this arc section and even the straight section here. And we'll start with that. And then I'll loft on the other side as well. Now, again, this is the benefit. This is the reason I like to use surface tools when possible, because it lets us do this one face at a time. It might take a bit more time to get a design, but you don't have to do this as one single solid operation. Now, sometimes the single solid operation is perfectly fine. It might even give us the exact same result in some cases. But in this case, I want to look at the shape and explore it as I'm building it, rotate it around, see how it responds to the light, and then continue on. Now, anytime you use a command, you can always right click and at the 12 o'clock position, repeat the last command. That's pretty helpful, especially when doing the same thing over and over again, like a loft. I'm going to use tangency. Now, this one is where it gets a little tricky. You can kind of see it's not staying straight. It's doing this sort of like wrinkle. And it's just because of how much it's wrapping around. So I am probably going to avoid that. So I'm going to hit cancel. I want to come over here and go to my solid tools. If I hit delete when I'm on surface tools, that'll actually turn the base into a surface, which might be okay. But what I want to do is hit delete here to get rid of that hole, because I want to create an edge that goes straight here that I can use to build the rest of that loft. That way I can control tangency on both sides. So it may take a little time. Then I'm going to create a sketch on this face, bring it up. We use our line tool, which is L on the keyboard. And then we will split face. So grab the top face. Our tool is just going to be that line. Doesn't really matter if it extends because we snapped to those endpoints. And now you can see we've got this edge. So if we go back to our surface tools and we use a loft, we're going to go from there. And then we're going to carry this across all three of those. And then we're going to add our guide curve over here and make sure that it's tangent. Now, because everything's straight, tangency is probably not going to do very much here, but it is good practice to make sure you are carrying the curvature across those edges. I'm going to take a quick second to knit all these together or stitch them together. While it's not required, it is helpful to have just a single surface body when you're doing that. And now we got the surface on top and the surface here. We could also connect those together, but I'm going to leave them apart for right now. And then we can try to build the other side. Now, because we have essentially a closed profile, we can use patch. I'm going to turn off enable chaining because I want to select the top, side, bottom, and this other side. And then for edge 2 and edge 4, I'm going to hit tangent here and see if that cleans up the shape a little bit. It's still looking kind of rounded, which is not what I'm going for. You can see that it's not straight. It's got kind of that bulge to it. So what this tells me is I likely want to split this up a bit more. Now, this is a true arc, and so is the bottom here. So we really shouldn't have a big issue here. There are some other things that we can do. If we go into our loft tool, and let's try this, see if it works. We can use the tangent edge option and closed, and sometimes that'll straighten it out. Let's just look at it from this side. It looks okay now. And the tangent edge option, basically what this is going to allow us to do is it's going to keep all of the tangent edges. So if it's trying to put one in the middle that we weren't seeing, we would be able to see that. You'll also note that the closed option, it's going to prevent us from using tangency inputs. So essentially what's doing is it's creating a surface with the minimal amount of influence. Now, because everything else is straight, it's actually going to connect just fine. But you may notice an issue if you try to do something like apply a fillet. So let's try this, stitch all these together, can hit F on the keyboard and see if the fillet carries across that edge. You see it doesn't. And if I hit Control, it's not letting me select that edge, which means it likely does have tangency and it does carry across. So I think this is going to be an okay solution for us. But sometimes when you try to loft too many profiles or too big of an area together, especially if the top and the bottom profiles are not exactly the same shape, in this case they are and we still have trouble, you may need to just work on some alternate methods. So I'm liking that shape. I think it's okay. I'm not going to do the fillet for now because I'm not ready to kind of round things off. But we also do want to make sure that we have enough coverage. Now you can already see that this has gone inside of where the original case is. Now, but one thing that's different here is I like the way that this shape is turning out. I'm going to bring this back to center, Control 4 to hide my edges. But I like the way that the shape is sort of working out as opposed to the original where it sort of dipped down and came back up. I like the fact that this looks a bit more like what a gearbox would probably look like. So I'm going to continue on with this, and then I'm going to add the secondary shape back here. And then we're going to use some surface tools to stitch them together. So what I want to do is I'm going to hide that mesh and bring my edges back. I really don't like to model without the edges on. And then I'm going to hide the surface temporarily, and I'm going to start a new sketch. So I want to create a circle at the center of this. So remember its point is not at the origin because it's a little bit off. And I want it to be exactly the same size because we don't have to deal with draft in this case. We're not worried about manufacturing this thing with injection molding. I'm going to make this arc and this one equal and then simply extrude it. Now the main reason for this is because I want this edge to be continuous as it goes up. So I'm going to bring this back. I'm going to extrude it as a surface. I don't want to extrude it as a solid, but I'm going to bring it up to about where that gearbox was, maybe just a little bit higher, and say okay. And then next I'm going to use a ruled surface from that same edge. And this time the ruled surface is going to go toward a direction. I'm going to pick the direction as that last plane we created and begin pulling this up. And then we're going to taper it inwards. Let's try negative 20 degrees. Looks like it's going to be positive. And let's try 45. Maybe even steeper, 60. All right, it looks like 60 is getting pretty close. Now all I'm trying to do here is extend past that plane. Now ruled surface will allow us to create a new surface based on an edge selection. When we use something like extend, a lot of times it'll be very similar. However, extend will connect it to the original surface. And in this case, I just want this new one. So let's hide that and let's bring this back. So the tricky part here is this is falling outside of this edge here. So if we want it to exactly match and come to that shape, really what we need to do instead of a ruled surface is loft it to a circle that exactly matches that. So I'm going to delete ruled. I'm going to come back up here and create a sketch. Again, I'm just going to draw a circle here, and I'm going to use concentric to make sure that it's concentric with this, and then equal to make sure that they are exactly the same size. And now we can just loft between the two. So we're going to go from this edge up to this, and now it's going to perfectly meet that edge. We'll say okay. I'm going to stitch these two together so that they are one single surface. And now we're left with the challenge of combining these two things together to either make a solid body or to get rid of the overlap. So basically what's happening on the inside of this is we've got these overlapping surfaces. Now trim can work if we want it to. We can also use things like split body. some of those tools will be the same. So for example, if this is my splitting tool, or that's the body to split, and this other one is my splitting tool, sometimes it'll work, but sometimes when they actually share tangency, like at this upper edge, because that shape wraps around, it's problematic. So my suggestion would be to patch the bottom of this big one off here, and then we're going to use boundary fill. So with boundary fill, I'm going to select all three surfaces, and then I'm going to go to my select cells. Now, boundary fill has been sort of broken for a while, and it looks like in the recent update they fixed it. And when I say broken, basically a lot of these checkboxes would be overlapping each other, so you'd have to hold down the left mouse button, and you get sort of this empty menu, which was really tricky. So for example, if I hold it here, we would have three things in this menu, and they don't have a name because they're just these sort of empty checkboxes. But it looks like in one of the recent updates it's been fixed. But basically what we're doing here is we're selecting those three separate surfaces, and boundary fill will let us fill the volume inside of them. So we're going to say new body. We're going to not remove the tools. We want to keep them just in case. So we'll say okay. And now we should be left with a solid body. But you'll notice that something weird happened. It left this sort of shell here. So we're going to go back to boundary fill, and it looks like I accidentally deselected that checkbox. And for whatever reason, it does not like that. So here's what we're going to do. Delete boundary fill. It changed the opacity of those surfaces. It's just something that it does. We're going to stitch the bottom surface and top surface together. That makes that a solid body. And then I'm going to go ahead and go to opacity and see if we can bring that back up. Then I'm going to patch this one to top. I'm going to go to my marking menu to OK, 3 o'clock position, 12 o'clock position to redo. We'll stitch these together. And now we have a second solid body. And so now we can join these two together. So we'll go to combine and select one, and then the other as the tool, say OK. And now we put them together as a single solid body. So there are going to be times where you have to pick a different tool because the one you're trying to use isn't behaving. That often happens with surfaces, especially when they're sharing sort of overlapping sections. So in this case, I'm going to go back to home view, do a quick save just so we don't lose any work. And I want to bring back the gear cover. So we want to take a look at the mesh again and just kind of see where we're at. So far, everything looks like it's pretty close to being outside. We may be a little bit inside the shape here, but that's so minor that it's not a big deal. And then all we really need is this extension on the top, and it needs to be the right size so that we can push the default plug in there. So Control 4, and I think it's looking pretty good. One thing I want to caution you on is at some point we're going to have to shell this thing, which basically is it's going to mean that we're going to be at the mercy of Fusion to see if this thing can even be shelled. So I'm going to try it right now just to see. And I'm going to give it a 0.4 millimeter, and it looks like it's shelling it okay. If we first add some fillets, so let's go ahead and add a fillet here. That's way too big. Let's say 2 millimeters. And let's try to add a fillet to the top. This is going to get tricky because of these sections here. So I'm going to try to combine them. Let's say 2 millimeters. And say okay. And now if we shell, all of those fillets are larger than the size that we're trying, which is 0.4 millimeters. So it should not have a problem. If I try to shell it up to 2 millimeters to where those inside fillets are disappearing and they're coming to a sharp corner, with prismatic bodies, a lot of times that'll work just fine and it can heal those inside edges. Because we have so many different angled surfaces meeting, we've got the top, which is flat or planar, coming to a tapered edge that has a 2 millimeter fillet. And then we've got some of those other edges sort of meeting in here. It's probably not going to work if you're trying to thicken it to that same value that you have for whatever those fillet radii are. Now we can go back and we can use things like a conic definition or chord edge, chord length for the fillet rather than a radius value. And the reason for that is because the radius value is a consistent radius. However, if the angle of faces changes, you're going to get a steeper or a thicker fillet in those areas. Now, this actually, surprisingly, it was able to do it. Obviously, it's not a perfect result, but it was able to get to the point where all of that went away. If I go to 1 millimeter, this is obviously much easier. It can calculate it a lot quicker because all of those fillets are at least 2 millimeters. So just something to keep in mind before you start adding detail. It's something to think about. Now, for just a quick test, if we change the radius type to chord length, and let's go ahead and let's change this to 2 millimeters, see if it can calculate that. Basically what happens when we're using a chord length, we're determining how wide that fillet is, and the radius value is going, it's going to make the width of that fillet consistent. Now, with chord length, it doesn't always solve for these complex changes. So you might find that you can't use it, especially if you get into a more complex shape. But let's go ahead and put that 2 millimeter back on there and say, okay. So far, pretty good. We are going to have to address this piece individually. So I'll have to put that hole back in it. We're going to have to cut away for the hardware, which is not going to be a big deal. And we may need to do some additional filleting and things like that. Now, I'm going to have to play around with that before we shell it. We're kind of doing this live at the same time. I haven't pre-modeled the shape at all. So anytime we run into problems, kind of what we're left with here. But let's go ahead and add this last piece of the puzzle. I am going to make it tapered and sort of follow that same shape. Because the top face is planar and because we're now dealing with a solid, there's not really any point to doing this with a surface. So I am going to just do a circle. I'm going to make it offset a little bit because I want to make sure that it is concentric with this and don't accidentally snap to the origin. Then I'm going to hit escape and just figure out what size it needs to be. D on the keyboard, it looks like 29 millimeters is about right. Actually, that's a bit big. So I'm just going to right click on the sketch itself, show the dimensions, Control-4 to hide my edges so I can see it a bit better. And then I don't want it to be on the outside of that fillet. I want it to be on the inside. So 27 looks like right where the root of that fillet is. So it's probably about 25 millimeters. So now what we can do is just extrude that. We're going to go up to a plane. I think we made a plane up here, plane 2. But actually, you know what? Let's just go ahead and let's do this manually. We're going to come up, and it looks like, let's see, 14. And we want to taper it in. Let's try 10 degrees, negative. And let's go a bit more until we see that popping through. So 15 is probably a bit too much. It looks like 12 is okay. It's hard to see because they're both gray, but there's a little bit of the mesh popping through there. So that tells me that we're sort of in the right place. And we're going to join it together. Then I'm going to do F to fillet. Let's try 2 millimeter. Say okay. And let's hide the mesh and bring our edges back. Last thing I want to do is try a fillet at the base of that. Let's make it a bit bigger. All right. And we do need one more thing here. So I need to do another sketch on the top. I'm going to do a circle, and then I'm going to bring the mesh back, hide the solid body. And what I want is that circle, let's go ahead and bring that back. That circle needs to be the inside diameter here. Now, the reason for this is we're going to split the top face, and we're going to use that as a selection when we shell it. So we're going to go ahead and give this a dimension value, looks like about 12.5, maybe 13 millimeters. Yeah, it looks like it's probably about right. So hide the mesh, bring the solid body back, and then we'll use split face. So split the top face using just that, and we'll say okay. So again, the main reason for this is we're going to use shell, and we're going to select the top face here. And we're going to turn off tangent chain. We want that face and we want this face. And if we go with like 0.5 millimeter, it's pretty thin. That it could potentially have problems if we're printing. If we go up to 1 millimeter, everything should still build fine. And I think that's probably going to be a good place for us in terms of 3D printing. And that gives us the lip that we need on the inside there. I'm going to say okay. Now we can take another look at this, and we can try to measure from the top to the bottom and see that's 1.3 ish millimeters. Now, of course, the scanner is not going to have a great time getting inside of there, but we can also take a look at, let's reset the selection, maybe go from inside to outside. It's coming up at about 1.3. So I think 1.3 is probably the wall thickness of that thing. So I'm going to go back to this body and I'm going to try to do 1.3 millimeters. Might be a bit thick, but it looks okay. I'm going to put a small chamfer on this top edge, maybe 0.5 millimeter. And then we need to address this piece. But before we do that, let's go ahead and go back to home view and make sure that we do save. So with the base of this, we know that we're working with 1.3 millimeters. I already have a reference for where these holes are, so I'm just going to delete that hole. And I want to add a fillet to these corners here. So I'm going to give it 2 millimeters. This edge is the one we split. I'm not too worried about it. If you don't like that edge there, I'm going to do Control-Z undo. You can select and delete that face, and Fusion will automatically patch that for you. In most cases, just make sure that you're in the solid tool, the tool set, because if we do that in the surface tools, if I select a face and hit delete, it's just going to convert it to a surface. So you can see basically just got rid of that top face. So you have to make sure that you do that in the solid tools. Now that we've got that taken out, the next thing that we want to do is bring back a sketch reference for where those holes are, and we're going to do split face. Now, again, this seems a little counterintuitive to do this now, but I want to shell this body out. So we're going to split the top and the bottom, and I'm going to split it with this. I'm going to bring that sketch back, and we're going to repeat that process. So repeat split face, splitting the top and the bottom. And for this side, we're going to be using that larger sketch there, and then we can hide our sketch. So the reason we did this is because we're going to shell this body, top and bottom, 1.3 millimeters. So we want that thin sort of band or that edge so that it matches our other shape. Notice that it does some weird stuff in the middle because that's 1.3 millimeters. But we're going to use direct modeling and select that face and hit Q and basically pull that up. And we're going to snap to a point here and say, okay. We'll do the same thing over here. So Q, begin to pull that up and then just snap to a point. And when we do this, that is not going to be a parametric relationship, but it will give us something to work with. I'm going to add some larger fillets in here. Rotate this around here and here. And let's add 3 millimeters, should be okay. And if we bring the other body back, now what we should have is sections that look like they overlap. Now what we can see here is the 1.3 millimeter wall, because of things like these fillets, it's overlapping a bit. And I don't really love that. So I'm going to change the shell thickness for this one. I'm going to change it to 2 millimeters, make it a bit thicker. And then we don't need these offset faces anymore because 2 millimeters, the entire vertical height of this extrusion was 3. So if the top is shelled 2 and the bottom is shelled 2, it's still an overlap between them. So we don't have to have that anymore. So now that we have these two, we can combine them. I'm going to join those two together. I'm going to select the red one first so they both become red. And then we need to extend that top face up. Now this can be tricky to do. What I'm going to do is go to Inspect, Section Analysis, and let's flip that around. I want to be able to see both of those. I'll just rotate it so we can see them both. And let's give this a try. So I'm going to select this top face and hit delete to get rid of those edges. And then I'm going to select it again and hit delete. And what I'm hoping will happen is Fusion will be able to extrude it up vertically and just patch between them. That is being very wishful. I don't think it's going to work. It might actually fail, and I probably should have saved it first. But it's always worth a try. Now, direct modeling and prismatic modeling are a bit different. But you can see it's not really working. So our next solution to this problem is to, well, I'm going to hit delete there and just sort of patch that bottom face. I'm going to take this face, just select it. Because it is planar, we can just extrude from it. And I'm going to extrude it up. And we're going to join them together. Now, when we do this, we obviously don't want to come all the way to here. We just want it to extend to the inside. We can bring it up higher if we need to, but 3 millimeters is basically the original height. But if we change this to object and select the inside, we may get lucky and be able to extend to it. It doesn't look like it. So because that doesn't work, the other option that we have is to basically build the inside face and then trim everything together. Now, this process probably would have been a little bit easier if the thickness of the base and the thickness of the top was the same. And that's something that we can always try. So we're going to save it, and then we're going to try that because it might be a little bit easier for us. So we're going to hit OK. Now, the quick way for us to do this is to go to our surface tools, select offset. And because the outside has tangency all the way around with the exception of that chamfer there, what we're able to do is quickly select everything. And I'm going to, actually, you know what? Let's hit cancel first. I'm going to remove this chamfer, again, just using direct modeling tools. And we'll do offset, select the entire thing, shift select the bottom, and then we're going to say OK. I'm going to hide the solid. Go to patch. I'm going to fill in this bottom section here. It does not like that for some reason. So let's try this. Let's patch that. Okay. And you know what? Let's delete this face and let's just patch the entire bottom here. And we'll patch the top. Now, sometimes when we're designing, especially when we're using surfaces, it can be, a couple steps forward and then a couple steps back. You might find that after you get to the end of a design, you could have done things a bit better. And that might be true. But in some cases, that learning process is very helpful and you just need to push forward after you have that core base shape. So sometimes that's the case. And because I'm not worried about maintaining some sort of parametric relationship between all of these, I'm okay with going back and doing it this way. So what we're going to try to do is split the bottom again. But this time, what I'm going to do is select the bottom face and offset this -2 millimeters. Bring back Sketch 5. And I'm going to project, so P on the keyboard, both of these edges. And essentially what I'm looking to do is make the inside shape that I want. So this is going to be construction. I'm just going to draw a new one. The reason I'm making it construction is, unfortunately, sometimes that construction geometry doesn't work quite the same as just regular geometry. I'm going to go ahead and put some lines here, make sure they're tangent, and then just give them a dimension. It's going to be kind of hard to see, but I'm going to put an angle in there. We'll say 45 degrees, and we'll do the same thing over here, 45 degrees. And then we'll work our way over here. So X on the keyboard, circle, we'll make those two equal. And this one's okay. I'm probably just going to fill it between those. I am going to trim and hit X. And then we'll use the trim tool again and we'll trim away the inside here. So that way we can fill it between those, and we'll do the same thing over here. We'll just get rid of that. All we're really looking to do is split the face. I'm not too worried about constraints at this point. So we're going to finish the sketch, go to split face, split the bottom face, and this should give us an entire chain. And before we even have the possibility of trying to shell this thing, let's go back to the home view and let's do a quick save. Make sure that we don't crash it. Okay, so before we shell this, let's go ahead and try to add a 2 millimeter fillet here. And it doesn't like it because of that transition. So we're going to have to come back and do that afterwards. That's okay. But now let's give this a shot. So we're going to say shell, we want the top and the bottom. Let's start at 1.3 and just see what it looks like. And you can see that it creates that little lip on the inside, which is not what we want. That's kind of what we were trying to avoid anyways. So let's go ahead and do 2 millimeters and see what it looks like, which I just remembered our fillets are 2 millimeters and it's going to be thinking on that for a while. Hopefully it doesn't crash. And it predictably did not like that. So we're going to go back to 1.5, but I am going to hold down Control and select this face as well. And we're just going to get rid of that face. So this is going to give us the clean wall up to here. If there are little sections like this, that's because there's a flat on the outside. So you can see that. It's not a big deal because we're going to add bosses back in here, but that gives us that consistent wall thickness that we're looking for with a little bit of extra work and run around that we had. But now we go back to Sketch 5 and we show where those hole locations are. What we can do is we can create those bosses. So we're going to try a couple of things. So bear with me here. We're going to hit extrude. We're going to leave the holes for last because we want to make sure that we just add the holes when we need to. They're going to just complicate things right now. So I'm going to select all the profiles. Go ahead and grab that. I'm going to just do one at a time. And I want to extrude up to object. We're going to use the to adjacent face to see if that works. And it doesn't look like it does. So instead we'll do distance. And we'll pull this all the way up until it goes through that face. So here's the problem, is that going through that fillet. So we'll grab that. And what we're going to be doing is we're going to be building out the shape, trimming it back so that we can join it together. So this is going to be a new body. It's a bit of extra work, and usually you don't have to do this. Sometimes you do, but we need to play around with it a little bit, unfortunately. So I'm going to have that body there, and we're going to work just on this side for right now. Let's go ahead and hide the sketch for a second. And let's hide this second body here. And the next thing I'm going to do is I'm going to create a sketch here and create a circle that matches it. Again, we'll make them equal. And I already have this. This is the same circle that we were just working on. Let's make it a little bit smaller. Make that equal to this one. And then we're going to extrude it up just to see what it cuts away. Right, so we definitely don't want to cut that much of the design away. So back in this one, we're going to get rid of the equal constraint. And for the head of the screw, it actually doesn't need a whole lot. Probably only needs about 4 millimeters. So I'm just going to make a 4 millimeter circle. I'm going to pull this one up and see what it cuts through. So that looks a bit better. We only have to cut into that wall there. We still want it to be a consistent wall thickness. And this is kind of why we have these two different bodies. So if we take a look at this one, this is going to be the solid portion that gets added to the inside, and this is going to be the portion that gets removed. So when we look at this piece, we likely need this to be a bit taller. And we can do that by changing the extrude height. We'll just make it come up a bit more. That way we can build out the geometry we need. Now the way that we're going to do this piece is going to get cut away from the rest of the solids, but we can use our surface tools and we can create an offset of the outside of this. And then let's hide this one. Let's hide this one. And now what we're left with is the surface and that solid boss there. What we're going to try to do is split body. We're going to try to split this body with our surface tool. We're going to say okay. And we can see it fails. So we're going to try this one more time. Split body, we're going to split the solid, split it with this surface tool. We're going to say extend, which probably is just going to, it's going to push it down the bottom. Say okay, and it fails. That's okay, because another way that we can do this is we can turn this into a surface. So delete the top, for example. And I actually want to extend the top a little bit, which again, I can go back and I can mess with the original extrude. I actually want to get rid of this as well because it's just going to complicate things because it's perfectly matching. And then what we're going to do is trim it. So let's go ahead and grab the trim tool. Our trim tool is this body, and we want to get rid of the top piece, but you can see it's not able to extend that out. And this is where using something like split body or split face is a bit better because we can select our surface as the splitting tool and we can allow it to extend, which should extend it here. If that doesn't work, then we're going to just have to extend it ourselves. Let's hide that for a second. Let's say extend surface. We're going to go tangent. We don't need that fillet. That's only going to cause problems. Turn off tangent chain and select anything that we need here. Pull that out. Just so long as it can cut through. Remember when we use extend, it's going to combine it with that original surface. So now if we try to trim, our trim tool is this, and the section we want to remove is that upper section. Quite a bit of a pain to get there, but now we have this shape, and if we were to do trim again, and this time we're going to use that cylinder as our trim tool, and we're going to get rid of the rest of that outside body, we'll have a solid that we can combine to the inside. Now, this is never the ideal workflow. Sometimes when we are dealing with complex shapes, the ideal workflow goes out the window because it's just a bit too complicated, unfortunately. But here, we're going to stitch these together. We'll say okay. And now we've got this sort of funky shaped solid body. So if we bring back this, we can join these together. And now we've got that boss on the inside. And we've got this one here, which we can remove. So combine, but we'll go to cut, the main body, and this is our tool. And now we've got the space that we need, to get that out. Now, I will say, I don't like that, the way that that looks. So what I'm going to do is I'm actually going to change this a little bit. And what I mean by that is I want it to be more square. So I'm going to use my line tool. I'm going to come out, over, come back. I need to make sure that these are tangent. And I'm going to project this edge. So P on the keyboard, make it construction, X on the keyboard, and then make these two perpendicular, make this one perpendicular, and that can kind of be floating out in space. I'm just going to give it a dimension. And so now what we're going to do is I'm going to hide that, and then I'm going to extrude this down to that face and allow it to cut away. So again, kind of a long roundabout process. We can add a small fillet there if we want, 1 millimeter, and then we can go back and add that hole. So definitely not what I wanted to do in order to make that shape. Sometimes you can get away with being able to just extrude up to a face. If we look at this from the bottom, this one we might have better luck with because it's only hitting that fillet in that face. But before we try that, again, let's save it. You never want to try something like this, like adding a fillet, shelling a solid body, or doing an extrude up to a face without saving. Now, I see a lot of comments online about people saying Fusion doesn't have great stability. I don't crash Fusion very often. I mean, once a month, a couple times a month, depending on what I'm working on. But it's few and far between. But I just know from experience, even though Fusion does save those intermediate files automatically, we can reopen them in the cache. We generally do not want to be reliant on that. So I'm going to go ahead and select all of this. And I'm going to say extrude up to object. That, try to extend the adjacent face. And again, we've got a problem. So we're going to go about this, extruding this surface up. So that we need to add, bring it all the way out the top. Just skip the solid step and deleting that face. So this one's going to be a bit easier simply from the fact that it doesn't cross over this bottom edge here. So when we do an offset of this and we do a trim, it should be pretty straightforward. So trim tool, set offset, and we want to get rid of this upper piece. Then we're going to repeat that. So now the trim tool is this, and we're going to get rid of everything outside of it. And for some reason that did not work. Oh, that's because we got the solid body there. Let's go back to that last trim. Okay, it worked. I just had the solid body visible, and that's why it looked a bit weird. Now that that's patched off, we can stitch it together, make it a solid, and we can combine it with this. Make sure that they are joining together. And once you have it combined, we can add a fillet here, for example. Let's check the other side, do that as well. Add a fillet there and there. And then we can add a small fillet to the inside. And then on the outside, we're just going to go from the same face height. I'm going to create a sketch, but we'll go back to sketch 5 and just project this. So P on the keyboard. And again, circle, I think we made it 4 millimeters. And then we'll just extrude all that out. Rotate it around. Again, this one's going to be a bit easier because it doesn't hit quite as much stuff. So that one can be that little recess. If we want it to come out the side, we can. So I could just go back to that sketch and redo that shape. So we'll project this edge. So P on the keyboard, L for my line tool, and we'll do the same thing over here. So we need to make sure that they are perpendicular. Make sure that one's perpendicular. I'm going to turn that inside one to construction for now. Finish sketch. And then if we edit our extrude, we should be able to hold control and just add that. So again, we'll add a small fillet there, just round it off. And the last thing that we need to do on those is actually extrude the screw holes. So hold down the left mouse button, select a profile, hold down control, make sure we do have the whole thing, and just pull them up. I'm going to make sure that these just go through all. And there we go. So that should be enough room for those screw holes. Go top view. It could be kind of tight. If we need to, we can make that a little bit bigger. So for example, this sketch here. And let's see, maybe make that one 5 millimeters. And then for this one over here, so this. So that was projected, but if we do a circle here and we make that circle 5 millimeters, we can get rid of some of these constraints and just sort of reconnect it. So basically we're just going to connect it over to here, connect it over to there, and it might give me an error. Let's go ahead and refix that profile. And it does not like something. Oh, 5's just too big for that inside. Okay. All right, well, let's go ahead. I'm just going to go back a step. And instead of 5, I'm going to make it 4.5. Finish that one. And then this one over here. Let's see. This one, 4.5. Well, so this is a good opportunity, unfortunately, for us to fix a few things. So let's go ahead and save. And let's try to decipher what is going on down here. Normally when I have to go back and fix something, sometimes you can get away with just rebuilding. Sometimes selection was just lost, But usually what you want to do is roll back. And the reason for that is, let's just say, hold down Control. So that's still fine, even though it's giving us a warning. It just needed to be rebuilt because that edge changed. And the reason the edge changed is because I changed that circle. I went from the original projected edge to a completely new one. So now the offset extrude should be fine. And then let's just take a look at this offset surface. So again, it just needs to be rebuilt. It just lost its original reference. And that's because the outside face is changed. So what this is telling me is likely I could have just hit Control B, which is rebuild. But generally the things that fail and don't rebuild properly are going to be the trims. The trims, because what ends up happening when a feature rebuilds, sometimes the selection that you made, that's a face on part of a surface body or a solid body, that's the selection that gets lost. And sometimes rebuilding them will flip those, which means that future selections for offsets and stitches and things like that will just be lost. Well, this is probably not a good sign. It's not making any progress on calculating this offset surface. If this doesn't crash, may need to roll back and recreate some of these features just simply because of reselecting that face. We'll just have to see. I'm going to let it crank for a little while and we'll see what happens. Well, magically, it did not crash. So in the spirit of things, let's do a save. And then we can move on to try to repair some of the other broken features. All right, so that surface rebuilt okay. And the next thing would be this trim. So I'm just going to roll back forward. Trim works okay. Second trim should be fine because originally these were just broken because of that offset. So now the patch should be fine on the bottom. Stitching them together because the offset is fixed should be fine. And then combining them together to make this body should be fine. And now the fillets will have their edges again. Should rebuild okay. Let's see. That looks fine. Double click the mouse wheel to get back. And then these should be no problem. And that's the last feature. So, took a little bit extra time, but we were able to get there. The last thing I want to do is I want to try to fillet this edge to see if we can. Yeah, probably not going to like it, but we can maybe do 0.5 millimeter and include that inside edge. Sometimes that will let us get around it. It's not required, and it's really not going to hurt the 3D print at all, but it just does not like this transition because of that edge there. And I'm not really sure that we need to fix it at all. 3D printing that, it's not going to be a problem. Now, the next thing that we need to think about with this is 3D printing, because it's basically done. We don't have to do anything else. So we're going to save it, and we need to decide if we're going to print it with support, if we're going to try to print it up on an edge or on a side. Because the critical aspect of this is going to be the holes, I'm going to be printing it in this orientation. So flat on the build plate, but with supports for the inside. Generally, I hate to do that because the supports are oftentimes hard to remove. But if I flip it over, the chances of that bottom face being flat, which is really the important thing here, there's an aluminum plate on the gearbox and the motor housing, and that's where we need to mount. So that, for me, is the critical aspect. Add a little chamfer here. So that's the part that I really want to keep. So save, and then we're going to take it to a 3D print slicer. So in order to 3D print this, first thing I want to do is I want to name it. So I'm going to call this RC Gear Cover. The reason for that is because the body name, because we're going to be just sending a single body to the 3D print slicer, that's going to be the name of the file. So I want to make sure that we have that. Now, depending on which printer you're using and which print slicer you prefer to use, you can obviously do this a couple of different ways. For me, I am using a Creality K1 Max. And with that, I have not been using the Fusion slicer in the manufacturer workspace. I was using that a bit when I had an Ender 7. But with the K1 Max, and it runs a bit fast and there are extra fans and things like that, it's much easier for me to just do save as mesh. I'm going to use STL and high refinement and send it over to the Creality Studio or Creality Print. Now, I have also played with the Orca slicer, and I prefer to use the Creality one personally. And I don't do this, or I don't send it over in a network, which a lot of people do. There are some benefits to that. But depending on which printer you're using, which slicer you're using, obviously you can do this in a bunch of different ways. Now, for me, I've got a few options and presets I've already configured. I am using a Hyper PLA, which is a 1.75 diameter. The Hyper stuff can be printed up to the max speed of the K1 Max, which I generally print somewhere between 300 and 500 millimeters a second for these fast settings. And I do have some refinement settings. So, for example, I've got a fast, no infill, no CDS. Now, for the K1 Max, the CDS is actually a fan that's on the side of the machine that points directly at the build plate. And what I found, at least with the PLA material, is that it tends to warp and peel up. Now, I went back and forth a bit on one of a Reddit post that I created, and a lot of people were saying the same thing, that the CDS fan, just turn that off and also bump up the build platform temperature to 60. So we're going to be running that at 60, and we're going to be running no CDS fan or side fan. Now, in terms of things like infill, this part is pretty small. I mean, 1 to 2 millimeter thickness. We don't really need to have an infill wall, so I'm going to print it solid. It's pretty small, so it shouldn't really matter too much. For the material itself, I'm going to be running 220 for the print, the extruder temperature, and 60 for the build plate. And then for the quality, again, layer height, we're going to run pretty small because it is a small part. The initial layer height will be a bit bigger so that we do have good adhesion. And then the extruder settings, again, we're going to be taking a look at these outer wall thicknesses of 0.42 millimeters. That's going to be fine for what we're doing. And build plate adhesion right now is none. This is tricky. I hate to use build plate adhesion for things like rafts, but with a part like this that does not have a whole lot of wall thickness or contact with the build plate, then using a brim is probably a good option. I don't want to use a raft because generally it's quite a bit harder to remove, but I'm going to use a brim for this. Some of the other things that we want to think about is going to be support. Now I'm going to generate support. I'm going to just allow it to generate it on its own and see what that looks like. So we're going to slice it with this. Again, high quality setting, so 0.1 for my layer lines to capture those angles a bit better. We do have a lot of small fillets on this. They generally don't print very well, but I think it's going to be okay for this design. Now we can see the supports on the inside of this thing. Go ahead and let's go ahead and just rotate that around a bit. As we go down, that support structure is really just there for that little lip on the inside, which is kind of a pain, but we do need that lip. It's an important part of the structure. And then we want to look at the way the build interacts with that support structure, because the inside face is flat, so we should not have a hard time removing that, but it is inside this tapered structure. So I might be regretting that decision. We'll just have to try it and see. You can see that there's brim for not only the outside shape, but also the support structure. So that should keep us pretty locked down. So I'm going to go ahead and run with that. I am playing a little bit of filament chicken on the material that I have on the machine. Hopefully it's enough to finish this off, but let's go ahead and send it to the machine and try to get it to print.
Well, now that we're at the end of our 3-part series going from scan to part design, it's time to reflect on what we've done. Now, at the very start of this, we talked about whether or not you actually need to scan a part. We looked at different variations of ways that we can maybe measure or get a part into 3D. And ultimately, for our design for this transmission or gearbox cover on this RC truck, we opted to scan it. Now, we had to go through and use scan spray, go through a couple variations. We added some small pieces of paper to the turntable to give us a little better chance of getting that feature tracking. And then we made sure we captured more data than we needed. Now that's always one important thing, is to take your time when you're capturing your scan data, capture a little bit extra just in case you need it, and then you can move into processing that data. Now we of course used RevoScan 5 for this. We can take raw point cloud data out of RevoScan and into something like MeshLab, but for the purposes of most users, you're going to stick within that ecosystem. So we went through, we cleaned up any mesh data that we needed to, and then we moved into Fusion. Now we used Fusion to create an inspired design. And what I mean by that is we're not truly reverse engineering it. We were using it to make sure that we can create a new part that fits or replaces it. Now the final variation of the part I think looks a little bit better. It's thicker and it's stronger than the original, even though it's just printed out of PLA. Now this is a good use case for the Revopoint Mini2 and other 3D scanners, is to take something that you have, for example, an RC truck or an RC plane, and you want to create a new variation of a part. You can use a 3D scanner to capture that design, bring it into the computer, and design your own variations. So if you have any questions on this process, please leave a comment and let us know. And as always, thanks for watching. We'll see you in the next one.